mean, just as I start to get the hang of Zoom, I'm leaving you all. It's kind of sad. So welcome. Good morning. Um, the first thing I wanted to do is let folks know that I will be leaving my position as ECMC Commissioner to go be the Executive Director of the Denver Department of Public Health and Environment. And I'm super excited. Um, a little bittersweet because there's some really smart people working in the oil and gas space, and I've really enjoyed working with everybody. And but it also means that there will be some change and some transitions. And Commissioner Messner has graciously accepted the role of the chair of the Biochar working group. So I just wanted to introduce him to everybody. And then Commissioner Messner, I didn't know if you wanted to say hi and just kind of talk a little bit about your background, and then we can jump into the work of the group.
Sure. Thanks, Karen. John Messner, Commissioner with ECMC. Glad to be here. I am a commissioner with expertise in land use and local government, which means that I don't know anything about biochar. And so, besides what Karen's talked to me and the different research papers that I've had an opportunity to read, but certainly am happy to chair the working group, but certainly I'm going to be leaning on everyone's expertise here to both educate me and to provide all the necessary information for the working group, and happy to facilitate that however I can. So thanks, Karen.
Welcome, John. I'm trying to think of how we'd like to work our way through the report. I don't know, Brooke and Holly and Thomas, if you all got comments ahead of time from anybody. Okay, so I'm a little worried that folks haven't either had time to read through or don't have comments, which would be interesting from this group. So do folks just kind of want to, and Holly and Brooke, I don't know if maybe you just kind of want to work our way through the draft, high level, what each section is about, what the recommendations or the conclusions were about. I really appreciated the summary statements for each section. I thought that was a really great idea. And then per the group's request, there is at the end that matrix, that table, the go, no go for whether or not the group wants to recommend a pilot. Um, so does that sound like a good way to walk through everything for everybody?
Yeah, I think so. I think that's a good idea. Obviously, we're looking for feedback. I know there's a few folks who asked whether they could start distribute and publicize the report, and certainly, it was our intention to indicate there was a draft, the report. So I think it's best that and I know there's a few mistakes that needs to be clarified. That we take feedback, revised, and then hopefully by the end of the month we would have something in a final form that could help direct the next steps. But yeah, I've not received any feedback except from a little bit from you, Karen.
Mhm.
Um, so we are of course hoping that people have some feedback, and even if it's not today, if it comes later, great. Just email Holly, me, and Brooke your feedback and your comments, concerns, or suggestions, and we'll try to the best of our, ability to incorporate that, since we obviously want the final product to reflect what this group was hoping to see.
That's great. So Thomas, that's something else that I've been thinking about and also related to the fiscal note that Janice sent, which is um, I think phase one is it kind of concludes at the end of the state fiscal year, which is the end of June here, July 1. And so I think that we need as a group to have some sort of direction to give to CSU and some sort of maybe decision today about a go, no go. Because if the decision of the group is this is a great report, putting together a pilot is premature or doesn't make sense or we don't want it, whatever, then we need to finalize the report, and then that is where the work of this group ends. if the decision of this group is, you know what, this is really good information to springboard off of, we think putting together a draft outline of or a recommendation for what a pilot would look like and things that needed to be considered as part of a pilot should be put together, then that I think would be important feedback for us to kind of decide on today as well. Because really there's a decision point here of July, end of June, um, as to whether or not we have funding to continue anything. Janice.
Absolutely. If I just absolutely, that would be the ideal. I just don't want to put so much pressure on people that they have to maybe make a decision today. But that would be our goal too, because I'm, kind of hoping, Holly will stay on board for a little longer and Brooke and so forth. And to the best of my understanding, the money has been set aside to basically help design the pilot between July and December. But we need the green light, of course, from this group on the go. So yeah, with that in mind. Sorry, Janice.
No problem. On that note, I just wanted to say it's an 82-page report. It's a wonderful report. Thank you so much. And I'm worried that we're not going to be able to get to this important stuff having to do with next steps if we go through it too slowly. I don't know about everybody else, but I read it in detail, and I'm ready to just go with comments and questions. I had very few. But I do think we need to discuss, there's still another $180,668 sitting on the table. We don't want to lose that. We want that to be applied to the next steps of, the pilot steps, if that's what we all decide to do. And we can't wait too long because of the deadlines in the fiscal year and so forth. So we kind of need to get into, where does it go now and what do we need to do to support this group to do more? Where does the money come? Is 180,000 enough? Probably not. Do we need more legislation? If so, I need to propose it now. So I'm hoping we have time to get to that stuff.
So Janice, I'm gonna recommend though a really high level quick walkthrough. We have 2 hours today instead of our usual hour, so I think that's helpful. Um, just because I want to make sure that as we walk through, folks understand, sometimes you read something and it's not really what the folks meant when they put it in writing. And so high level, real quick. And I agree with you. We need to get to some of this meaty stuff. Stephen.
Yeah. Can everyone hear me okay? It's my first time using a phone in this thing.
Yeah.
Good. I wanted to echo Janice's sentiment, and I want to be respectful of the need to provide input on a path forward in a timely manner. I am coming to this from the space of environmental justice, and I do have some concerns I'd love to discuss with the group in terms of the overall path forward and kind of where that can be incorporated into this process. But I'm all for trying to be productive and the constraints that we're working under. Thank you.
Other thoughts from the group?
I have only skimmed it, and I do have comments. I wasn't sure what the best way to give comments would be, whether you want it orally. I can't edit on a PDF file, so just curious. But I also thought it was really well done, what I read, very thorough, and I really also appreciated the plain language stuff up front.
So Holly and Brooke, do you think it would be best if we went through, and maybe for the group, if we go through each section, and if you have a comment about the section that we discuss, maybe that's a good way for us to combine a review of a section and any comments you have about a specific section. And then when we get to the end, we can talk about the report overall and some next steps. Is that agreeable with the group? All right, with that, Holly and
I
Brooke.
mean, just a comment. I mean, we prefer written comments. It's a lot easier because as we
Yes.
have to, so
I
you just
agree,
use the,
Thomas, but I think it would be important for people to hear each other's comments
yeah, of
in this
course.
group.
Because if you have written comments and if you can use the track changes version in a PDF document, that's way easier because you can be a little more specific. You can put in references and our group can better incorporate. So anyways, let's go over the summary. Do you want to start out, Holly?
Let me get it pulled up real quick on my screen. Okay, so I'll take the first couple sections. So the first kind of the way that we laid this out was we started with a motivation section that is kind of separate from all the individual tasks, just to kind of put everything in perspective. So that's just a lot of background information, um, not really necessarily directly um, related to an individual task. So the actual tasks from the bill are all written out in the research tasks section. And so all of the italicized sections are the actual language from the bill. We didn't change anything there. That's specifically what it said. And so kind of the first task that we put up here was the peer review of articles that are related to a number of different ways that biochar could act within plug-in abandonment. And what we found was that overall, there's a decent chance that biochar could potentially lower greenhouse gas emissions. It might be able to act as a chemical sorbent for leaks or for binding gaseous chemicals as well. Potentially, we could sequester some carbon within the wells using the biochar. And then there were a number of articles related to adding strength to cement. And we really found that there's just a lot of variability within biochar. It's kind of a catch-all word where you can put a lot of different things could become biochar, and that all affects what the final product is. So overall, we thought a lot of the literature looked really promising, but there is a good reason for us to test our specific biochar that we're going to use for any of these applications. Brooke, do you want to add anything to that or?
The only thing I will add is if you skim through and you see the table for the net greenhouse gas emissions associated with biochar, I did specifically keep the literature review of that table to woody-based biochar because that is what we are evaluating in this study.
So a question on the LCAs. Are you just relying on what was in the peer reviewed? So they could have been using different LCA methodologies?
No, I don't believe I used the peer review table. It was a combination of talking with some producers and finding those LCAs that existed online with certain producers of the biochar, as well as looking specifically at pyrolysis methods that are like the specific reactor to what I evaluated. And I really tried to focus on that specific reactor that's used for pyrolysis with a woody-based biomass, and ideally with a process that optimizes biochar production. There is limited studies on optimizing biochar production. They normally optimize bio oil or other products, so that was more difficult. But no, I did not use these references specifically.
I will just say that I found those numbers fairly low when you compare them to what you hear Puro and others using as their carbon multiplier. I mean, it's usually between 2.0 and 3.0. But again, that's why I asked if you're using a standardized LCA to normalize those numbers or not.
These specifically only include like the pre-processing and the thermochemical conversion method. That's might be why it's lower. Because some of these, if you go through the reference, some of them were used in soil and they added some more sequestering ability into it. And it's like avoided use of fertilizers. So that's not included in this
Yeah,
table.
that's not normally included.
Yeah, yeah. So the system boundary is like the pre-processing up to the thermochemical conversion. But each LCA, I mean, there's some variability with each one. So.
And I mean, one more important thing is the fact that, you know, our collaborators from the Forest Service, Forest Service did, make a huge calculation with respect to how much woody biomass that would be available for biochar. And as you can see in that report, more than enough. There's at least 10 times more woody biomass than needed for the orphan wells. And I don't know if that include, I know Karen, you wrote an email saying that we got that number totally wrong. So that might impact some of these calculations on how much woody biomass that is available for biochar.
Mhm.
Well, on that note, there was a very interesting LCA done in the last year, funded partially by the U.S. Forest Service, looking at these air burner systems and woody biomass. And the number they came up with was 2.7. So that's why I say, even on that kind of machine where you're not utilizing the heat for drying or anything like that, the number was a lot higher than what you had in what I read quickly in your paper. And I'm happy to share that LCA if it's of interest.
Yeah, certainly. And it might have been something I've already seen, but I'm happy to see it again and kind of figure out why it's higher than what I have.
But maybe as a change for that section, Brooke, it would be good for us to maybe benchmark a little more, just a little bit. Some of the studies that Kathleen is referring to, maybe discuss our findings relative to them to help explain why there's a difference, because there might be an easy explanation for why the numbers are different. But I think that's important to incorporate into this report, since it will become public and people will question everything. Um, Even just a discussion, the number might be what it is based on the assumptions we are making. And then if you make further assumptions, that number could be higher or maybe lower.
Yeah, I think you'll get a lot of pushback from people in the carbon markets with those numbers. So I think that's a great idea to do that, Tom.
I mean, overall, is the assessment from this group that we should be conservative in our estimates so that you could say, at the very low end, the benefit or the numbers look like this. I mean, something for the group to think about, and that's a way to maybe couch this conversation and the study and the numbers that are being used or not being used. Okay. Any other questions about this segment or comments about this segment? Janice.
Yeah, where in the report are you referring to right now? Just so I can make my notes.
Right now, I've been talking about the table 1 under the net greenhouse gas emissions associated with biochar.
Can you give me a page number?
Page 12.
Thank you.
And then Stephen, did you put your hand up again?
I did, yes. So with regard to the table 1 and this section being concerning net greenhouse gas emissions associated with biochar, I think that this could be an opportunity either in this section or perhaps in table 10 to address the potential for additional emissions associated with biochar. I know that it's kind of a moving target given the amount of variability and kind of the catch-all nature of the term. But moving into the next phase, particularly with a pilot, I think that from the EJ perspective, it's worth consideration of the additional emissions from this source, and something that should be worth considering, given that in my mind, a pilot is successful, then it kind of significantly ramps up production. So for me, I was reading through this section looking for kind of a nod to the fact that there are additional potential emissions and impacts, with the caveat that, of course, this is a greenhouse gas section. So just that's my overall thought on the report, is that it leaves a little to be desired for the next phase, given that this phase had very specific legislative goals and constraints. But I'd love to see that as a recommendation moving forward.
Stephen, can I just clarify what I think I heard you said, which is we need to acknowledge that the production of biochar itself can cause emissions, or sorry, I just want to make sure I'm understanding.
Yes, I think that's worth acknowledgement. We see it on page 56, given The final paragraph in the report sort of touches on the potential health risks associated with other contaminants like heavy metals and pathogens, depending on the source of the feedstock, as well as the impact of odors and emissions to local air quality. I think that that is something that should be acknowledged in the early section of the report, just given that we had blinders on and we were looking at specifically greenhouse gases, but that there's more assessment to be considered, especially if this is an industrial activity that's to be ramped up in the state.
Okay, thanks for that. And then, Stephen, I don't know if you can see the chat on your phone. Someone commented that emissions from biomass and biochar production are usually factored into any LCA. But maybe that's worth also mentioning as part of this discussion in this section. Okay. Janice, you had your hand up?
Thank you for that.
Yeah.
Yeah, I had my hand up, and Stephen, I made notes of that too. And on page 56, you're right at the end, there is some good language about emissions from biochar manufacturing affecting communities. And when we get to that point, I have some copy change suggestions that might make it a little more specific and address your concerns a little bit more. I agree, it could be mentioned earlier on, but I think that like most people take an 82-page report and they're going to look at the end and go, okay, what's the final recommendation here? What's the final what's the final summary? And so having it at the end there is really kind of pride of place. And when we get there, I'll make my suggestion.
Okay. Stephen, your hand is still up. Did you have more to add, or are you good?
I just wanted to add that it is important, and it's good to know that it's typically factored into another LCA, but given that the intended audience for this report, I think, wouldn't be privy to that additional information. So I think that it's worth, promoting that idea early and often, as well as to Janice's point, I think it'd be a worthy inclusion into Table 10, but we can have that conversation when we get there. Thank you, Janice, for that.
Thanks, Stephen. Okay. Everyone good? Okay, let's move on to the next section.
Okay, so the second section asked us to look over whether or not there were any laws that address the use of biochar in plugging oil and gas wells. And across the board, we were not able to find any direct mention of biochar or other supplementary cementitious materials. Kind of one of the most common ones is fly ash. And so a lot of times we can apply some of the findings or discussion about fly ash to biochar itself. So we weren't able to find any of that directly. And so kind of what we found by reviewing state and federal laws is that biochar is probably not considered a normal material for plugging. And so we will need permission from whoever is managing the wells, if it's state or federal. That's kind of out of my personal purview. But we will probably need a special permission to go forward with this.
I think that's right. And I think I saw somewhere, Holly, specifically, if you're working with ECMC, there's going to have to be a variance request because the rules, law maybe not, but the rules are pretty specific about how we plug wells and what materials are eligible. I don't know if that's the word, Mike, but how it's done and why it's done a certain way. And so I think that at minimum that would require a variance with the state entity, and I don't know how that would work with our federal partners.
Yes, and I think that there are some requirements for proof of whether or not we're meeting the current requirements that are in place. And I think that would be part of the pilot program, is identifying who we're going to ask for permission from and then working with them to make sure that we've checked every box that they want within that pilot study to get the permission.
Yeah, that's definitely our request as we move forward. If we move forward, that over the next 6 months, we need a contact person who can help us with the regulatory side to make sure, because if it's a no-go with respect to using biochar as a filler or an additive in cement, then it's done. We're done, right? I guess, but I don't think it should be too hard, to potentially get the permission to use biochar as a filler at least. I think that's really our recommendation, as you can see in the end. Whether we need to even consider it as an additive, we can discuss later for cement. But we definitely need to get help on the regulatory side of the equation in order to move forward. So,
Janice.
Yes, I think somewhere in this report it mentions that the Department of Interior handles the federal side of it. And so that would be a good person to get in a regular attendance on the next section to talk about that. And I'm wondering, since I proposed the legislation for this and saw it through the legislature, does anybody here think that we're going to need more legislation? Because if we are, it's soon we have to start in order to get something on 2025. So just be thinking about that. And if I could get a recommendation from you, Karen, about that, or anybody on the ECMC about just what we're going to need in order to do a pilot, that's going to be crucial, I think.
Okay. Aaron, and sorry, is Carmia still here? I'm curious to know, for our own edification, if the BLM would be the entity to ask for a variance from, or if it is the Department of Interior. Aaron.
Yeah, Karen, that's what I was going to say. Is Carmia Woolley from this BOM state office is on. So Janice, I think that's probably the place to start, but I'm not sure, Karen, if Carmia is still available.
I think she unmuted. There she is.
Yes. Hi, good morning. So yes, it would be the Bureau of Land Management where you would, require a variance, and we would be working with probably state office staff, but then also headquarters staff to make sure that yes, we're following all the rules and minimizing risk.
Just one quick question to you, Camilla. If we over the next 6 months or so are developing this potential pilot project, are there any goals for what it would take to get permission for putting biochar in as a filler? Is it, for example, we're talking a lot about these geomechanical tests, right? And one could, for example, play with different fractions of biochar, bentonite, and water, and do compression testing on the well casing to make sure it can withstand the pressures and temperatures, and that the biochar within these wells do not behave abnormally. What is it actually? What type of information do one have to provide in order to get regulatory approval for using different types of fillers? Just a person or an idea, just for us to start thinking about that.
Right. I honestly, I'm not a petroleum engineer, so I'd have to reach out to those specialists and get back to you.
Okay, thanks.
Unfortunately, we're missing some of our ECMC folks too, but I think Dave and someone on the engineering side would be important to have as part of this conversation. And I'm sure Mike has, I was just going to say, I'm sure Mike has some thoughts too. So Mike.
I wish Dave was here as well. I will share my 2 cents, maybe out of order because I think we're going to get down to those sections here very soon. But if I were going to present at hearing and say, commissioners, may I have a variance for this? I would want to come in with testing to say, this is what I need to do to meet regulations. It's compressive strength in 408. It's free water in 408. There certainly isn't anything in the regs about putting it in the spacer between plugs, but you would want to show up at hearing and say, we have done the tests. We've met regulation. This is why I think you should approve a variance. As Commissioner Messner pointed out, all the commissioners don't have expertise in all these fields. So you need to go into them and say, this is what we've done. This is why it meets regulation. This is why we should proceed. So a lot of the things that CSU, you guys pointed out in the research, and I will say I'm very inspired by the body of work you guys have done. It's very tremendous. But you guys have pointed out that you've done these tests. You're still needing to do more tests on compressive strength. You didn't really address free water, which is in 408, but that wasn't part of the charge on this. You're going to want to do those things. You're going to want to make sure it's down pat and say, this is exactly what we can expect. That's what you're going to want to do to come to hearing.
That's very, very helpful. Yeah. And we have some connections to a national lab that can simulate the high pressure and temperatures. So we can basically, for example, the cement, if you're going to use the additives in cement, we can do these tests potentially at a national lab and then get the data that can then be put forward. The filler test, I guess we can do that too. But anyways, this is great. Thank you.
I think potentially maybe part of the conversation for this group, something to consider or contemplate is, does a pilot have to actually use an existing well that's been orphaned or that we're trying to plug? Or could a pilot be real world conditions, but not an actual well where we're putting something at risk or the safety of something at risk, but you're using real world conditions, downhole drilling a well or whatever, like that could be your pilot. So just something for everyone to think about. I don't know what Mike thinks, but I don't know how many operators would be like, we'd like to test this out and ask for a variance and try it. Folks, I mean, it's kind of stick to things that are tried and true. And so anyway, just something to think about. And then Stephen, I saw you asking whether or not we wanted to put up on the screen the draft. If I put up the screen, I think I can't see people raising their hands if I put up the presentation on Zoom. And so I am not going to put up the presentation because we're all in a danger zone when Karen tries something new here. So I don't know how other folks are feeling about I know you're on your phone too also, Stephen, so I know that's tough. I don't know how other folks feel about putting this up on the screen or if everyone's okay following along on their own.
They can
And
just
then,
reference page numbers. That would be
great.
helpful.
Thank you, Jenna. And then Jenna, you had a question too. Oh, we don't have to open up a well that's already been plugged. We have wells that are orphaned or an operator might be plugging wells on their own that could be eligible for a pilot. You wouldn't have to open up a plugged well per se. Was that your question?
Yeah, and actually, I think you sort of touched on it when you said, your comment earlier about, whether we have to use an actual one or simulated for real world conditions. So, because that was a question that we had on our side too, was if anything was going to have to be opened up, then we have to start thinking about air emissions and what waste is going to be brought on site with our has waste folks. So, but I think you did sort of touch on that earlier.
Okay, great. Any other questions for the kind of the research on legislation, laws, regulations, etc.? Something else maybe for us to contemplate as part of a pilot is, looking at the regulation sections. So for us, if it's the 400 series, Mike, what is it for the feds? And then for a pilot, what would you need to show or prove to get a variance? That could be part of a pilot discussion also. Okay.
Okay. Oh, Janice.
Sorry, really quick. I just wanted to address this idea of doing a pilot not in a real well. I think all the way along with Representative McCormick and people drafting the bill and all of us that have been working on it for years, the idea was to do this study in the desk study and lab study, and then move into a pilot where it is actually in real wells. That has always been the assumption. So to change that now, I think is a big departure and would need more than just more than just a casual change.
Yeah, I would say in ideal world, the way I've see the vision for this project, if we move forward, would be to do all the testing as you would normally do, whether it's cement or well integrity testing in a lab, big labs, that can do this under simulated conditions that represent temperatures and pressures. And then when we feel comfortable and confident, that we meet the criteria for pressure testing, for example, then we could move forward. When we are convinced that we are not potentially blowing up a well or causing any harm or causing collapse. And I think so basically follow the normal procedures for changing a cement mixture or changing the ratio of bentonite or drilling mud to water and so forth and so on. I think that there's this mesoscale experimentation that needs to be done before we go all out. And that would make also the most financial sense, and it would also help us design and optimize the best, because we would have to test a lot of different ratios of biochar, bentonite, and water, for example. We would have to test different sizes of biochar, different types of biochar. So there's a lot of testing that can be done at a mesoscale. Mesoscale is something in between a lab and a field study that can help guide us for the best recipe for when we go out in the field. But obviously, I think it would be it would make a lot of sense to do this in a real world and show that it can be done, so it doesn't just end up as a report on something that is hypothetically possible.
Thanks, Thomas. Thanks, Janice. I think to Jenna's point, then we probably, as we're thinking about what a draft study would look like or a draft pilot, making sure that we're considering all the things that the various regulatory agencies will be looking for and requiring as part of a pilot, and how the path to get there.
Exactly. And that's how I see the next 6-7 months, go basically lay out everything that needs to be done, at what scale it needs to be done, in what order, so that come December 31st, we have a clear roadmap for the experiments and targets that we need to hit in order to eventually, carry this out in the field. But there will be a lot of lab mesoscale work that needs to be done before we can go out and play with real wells.
We don't play with wells, Thomas. Okay. Next section. You guys ready? Okay.
Okay, so the third task starts on page 21 and addressed some geomechanical modeling. And so initially we interpreted this to be some modeling that would relate to helping us decide what experiments we would carry out, kind of identifying important components of the combination of biochar into cement specifically was where we focused all this. We were not able to do any geomechanical modeling ourselves. So what we did was review kind of the related literature that exists already, some models that are already out there. We were able to identify that there is still quite a bit of variability within these models, which kind of felt a little bit risky to base all of our findings off of experiments that we didn't do ourselves and that we weren't able to test with the same materials that they used. Again, since the feedstocks are so important with the biochar characteristics, we weren't able to find a whole lot specifically on woody feedstocks within these models. And so really what that led to was a conversation with Representative McCormick back in April, where we agreed that the best use of our time would be to really focus on the experiments in the lab and address some of the questions that were left over from reviewing the literature and reviewing the geomechanical models, really trying to answer those questions for ourselves in the lab. And so we identified that pressure and temperature are going to be pretty important for curing. Biochar is expected to change how the cement cures. And then I think going back to trying to do some models now that we have some of our own results might be a better use of our time than trying to start with the models and then go back to that. That was a little circular, so sorry about that.
Any questions or comments for this section? All right. Who's got the next one?
Okay, I'll just go ahead and jump into task 4 then. That will start on page 24. I'll summarize it. Carrie, correct me if I'm wrong or I overstate anything here, but task 4 was where we did all of our laboratory research. We designed an experiment or a series of experiments to look at the mechanical strength, some permeability and pore structure, and then look a little bit at gas absorption into the biochar. For the geochemical reaction of biochar with water from an underground formation, we made cement molds with biochar in them and then kind of cured them in produced water. And then we also kind of looked into some of the chemical reactions that might be occurring within all of these different systems. And overall, I'd say the results were they were fairly promising. We do need to redo a few tests, but we found that with relation to the amount of biochar that we could add, we kind of tapped out at about 3%. We were trying to keep the viscosity of the solution down. We'd been advised that that was a very important variable for actually pouring the cement. So it's likely you could get a little bit more biochar into the cement, but you might have to, it's that balance of viscosity versus the amount of biochar you can put in here. So we kind of limited all of our tests to 3% biochar addition. When we exposed that to sulfate and chloride mixtures as well as the produced water mixture, we found that a lot of times there were some initial improvements in the cement curing, but that over time everything kind of leveled out and the cement without biochar and the cement with biochar kind of converged in the same spots. So it looks like it's not making it better, but it's not necessarily making it worse either so far. We did try to look at heat resistance, but the blocks kept drying out, and so those results were not good. So we're planning to retest those in a water bath so that those don't dry out again, and we should get much better results, and we're expecting better consistency from those as well.
That's actually in progress right now, so I should have that not too far from now.
Yeah, and just in addition to this summary from Holly, I mean, I was intrigued by some of these sulfate and chloride attack tests because it appears so chloride and sulfate, and especially chloride from oil and gas situation is, can really cause disintegration of cement. And it seems like if you include biochar in this cement, that it actually seems to resist better potentially both the chloride and sulfate. Obviously, we have only been experimenting with this for a few months, and so that's very interesting because the integrity of that cement is definitely, influenced by chloride. But again, I mean, you can make the argument if every cement block that is being implemented now is fine and keeping up just perfect without jeopardizing the wells, there's maybe no reason to improve the chloride resistance of the cement. But anyways, we have some hypotheses to why biochar might actually make it better from the perspective of resisting chloride and sulfate.
Mike.
I was very excited to read through this section. I think there's a lot of excitement around making cement stronger. Ion resistance is great too. Thomas, I'll kind of I like what you said, and I'll bring us back to the CSU Riddick study that we're all familiar with, that plugged wells in Colorado do not have emissions. And as an operator, when you get the commission to sign off on your Form 6, you are done. That, you know, emissions from plugged wells is not a thing. I want to make that clear, and the fact that the Riddick study is part of this is a big deal. So now on to my question. I want to make sure I understand a question I'm going to have further down, and I'm going to ask it here. Will you guys help me understand, for the gas sorption, when you're trying to say, I've put biochar in cement and it's going to absorb this much of a gas, are you assuming in the study that you did or the literature that you read, was it based on curing biochar in cement and then crushing it and then seeing how much gas it could absorb? I just want to make sure, because my question further down is, when we're calculating how much it can absorb, are we talking about in cement, out of cement? Maybe you can answer my question and I can come back with a follow-up.
So I can answer with what I did with the BET study, if that's the result we're looking at. We look trying, because I like one of the main things of interest is methane or organic gases, and we looked into trying to look at those gases with our BET analyzer, which just we couldn't do. So the results I have are from nitrogen, and it's from what I understand, I'm still a little bit new to this field. But from what I understand, like the nitrogen sorption is used to calculate surface area, and it's under extreme pressure. That's not really a good representation of how it would actually be absorbing gas at more normal temperatures, or sorry, pressures. Holly, correct me if I'm wrong. But so what I did with those, I'm running the control sample right now as well. So I should have a good comparison in a couple days. But so what I did is I had my 3% mixture, and then once I crushed it after 28 days of curing, which it should be like at almost, it should be completely cured. I just used the crushed like already, it was already cured. It was just cracked. So I crushed it into like not a powder, but like I said in the report, like pea-sized chunks. So it wasn't like a big slab and it wasn't a powder. It was kind of somewhere in between. And I used the fully cured cement. So if we wanted to look at just the sorption of just the biochar, like I said, it'll still be more of a measure of surface area and porosity than actual real sorption, but that's what's in the report.
No,
So
perfect. I
just,
appreciate that.
yeah, and I just want to say for that particular test, we do have to break it up a little bit. We can't measure it in large chunks, just the way that the instrument is set up. But there are some other methods for looking at the sorption potentials. CSU was unable to, like our lab and then our main lab here at CSU, was not able to change out the gases in order for us to look at other ones. So that's why we stuck with just overall surface area for now. And then it would be very to reach out to some other labs here, sure, and see if anyone else is able to switch out the gases to something other than nitrogen. That's just kind of the normal way to measure this. So.
No, I appreciate that. And I just want to make sure that if we're predicating this on the potential to absorb, great. Let's say that it is only the potential. Or if we're saying that we know biochar in cement will absorb so much, and whether that be CO2 or hydrocarbons that come from the reservoir, is it a potential or is it actual? And I want that to be plain for everybody. Thank you.
Yeah, I think that needs some clarification for sure. I mean, so for example, an example, you get really small pores, you would measure the surface area using krypton gas, because gas molecules do have different sizes. And because they're different sizes, it will impact the amount of sorption you can have for these different materials. You can actually pipe the surface area analyzer to work with methane, like Holly was pointing out. But the question is, I mean, when you have this cement surrounded by a fluid, one of the things that is very important for you all to understand is if you base gas sorption based on a Bennett-Emmett-Taylor surface area analysis, the first step you do is you heat it up and you dehydrate it. You always dehydrate these materials to make sure there's no water film surrounding the material. Because if there's any water on, you can't measure gas sorption and determine the surface area. So I think this whole experiment needs a little more thought. This was the best we could do with the time we had. So let's make sure it's clear what we did and what we did not do, and whether it's a potential or not. And then going forward, we should actually execute these experiments. Now, again, the question maybe to the group is, how important is sorption of gases to this cement that is submerged in produced water? Or am I misunderstanding something?
So I just want to, again, it's like being in science class for me, or chemistry class. I'm not sure which one it would be. Mike, did you get your question answered about whether or not we're talking about the potential or actual ability for biochar to absorb what we're looking at?
The CSU folks made comment on that, and I don't think it's settled, but I appreciate the comments that were made. The
Okay.
Thomas said it needs to be clarified further.
Okay. And then, Thomas, I'm not sure that you got what you wanted back from I didn't know what you were saying was a rhetorical question about the produced water and being in contact with it, or if you need feedback from the group. So could you please clarify that? And then Kathleen and Janice had questions.
Yeah, two things. So, since just for Mike, the first thing, the way these surface area analyzers work, Mike, is you determine based on the material that you analyze, you determine what a monolayer adsorption of nitrogen molecules look like. So basically, if you only have a monolayer, so not stacked layers of nitrogen molecules on the surface of this cement, you basically try to determine how many nitrogen molecules represent a monolayer coverage. And that can be turned in with an algorithm to a surface area. So what that means too is we are not talking about filling up all the porosity in this material, the gas molecules, since this is based on sorbed nitrogen molecules on the surface. That's a very important distinction. So back to what Karen was getting at here, the feedback I would like here is we did see that the group would like to understand how much gas that can be sorbed within the cement. My question to the group is, under what circumstances? Is that when you have a cement plug basically in contact with bentonite, produced water, and so forth and so on, and why? I mean, yeah.
So you folks as a group, if you have thoughts, if you don't have a thought right now, exactly, hold on, but send Thomas and the group some thoughts about what it is that you're looking for. That would be helpful. Okay, Kathleen and then Janice.
A question and a comment. If this is going to be a publicly available report, do we have permission from the 3 companies that you got biochar from to put their names in there?
We did not directly discuss that with them. So before we finalize the report, I will touch base with all of them to ensure, we can either mention them or not.
Yeah, I would guess 2 of them don't want to be mentioned given the results that you found. So, and then the other thing was kind of related to that is because we don't in the industry really know yet what the specifications are that are relevant. I mean, we're starting to get an idea for concrete. I don't think we have any idea for, replacing bentonite and looking at viscosity and all that stuff. I think just having three, based on the criteria of they have to be from Colorado, was probably not the best way to get to the best result. And if there was a way before we go to the next step, if that's what the group wants, to kind of narrow down what those qualities are in the biochar that matter, you started to get that to that a little bit with particle size and stuff like that. I think that would be helpful.
Yeah, I think right off the bat, we can definitely say that particle size matters a lot. The smaller the particle, the better, so far. And then also the number of inorganic impurities was very important as well. So kind of the cleaner, most carbon-rich biochar that we can get so far has yielded the best results.
Yeah, and then just one last thing. If particle size, small uniform particle size is a relevant quality, that's going to impact your LCA, most likely, unless you're getting sawdust biochar. But just wanted to throw that out there.
Yeah, and just a comment to Kathleen too. I think maybe you're saying you would not make two biochar companies happy. I think it's important to put this result and these findings in perspective, the following perspective, that we cannot use more than maybe up to about 3% of biochar as an additive for this particular cement is because of the huge demands for the application for oil and gas, well plugging. Okay, the demand for this cement is very different than if you go out and pave, bicycle lanes with or whatever you do, with this type of cement. Other types of cement, you can put a lot more biochar in and get away with it. But the integrity and the regulations and so forth and so on for this particular cement are very high. And that's why we can't push the 3% limit. So it doesn't mean it's not good for cement and it shouldn't be used for cement. It probably just cannot be used in high concentrations for cement used for oil and gas well plugging.
Yeah, I want to jump into that really quickly to just remind everyone of the mixture. We're not using any large aggregates and we're not using sand as a small aggregate either. So this is a neat cement mortar with a little bit of biochar tossed into it. So in applications where you would be using aggregates, you probably could get away with a lot more than what we're doing right now.
I just want to add to that as well. Like even with like you said, a little bit of biochar, 3% biochar by mass is like, it's not an insignificant amount of biochar. Like biochar is very, very lightweight and cement is very, very heavy. So like when I made the 3% mixture, that mixture is jet black, like because of how much biochar is in it. So like 3% biochar doesn't sound like that much, but it's a lot of biochar.
Gary, if you could ever depict that, it would be really useful to people. If you have a picture of how much of each you need.
Yeah. I have a lot of images of the fully cured cement and like you can see the color difference pretty clearly between like it's pretty easy to see the difference between like a control, a 1% sample and a 3% sample when it's cured. It's not that amazing jet black you see when it's still a slurry, but I have a lot of those pictures. If that would be helpful, I can put those in really easily.
I thought we had a few pictures. I thought in one of the drafts I looked at, we had pictures but maybe I'm mistaken, Holly.
I think there's some in the appendix, but
The appendix. And of course, when we say a lot, it's a lot by volume because of the density.
on page 76, there's a couple photos from when Carrie looked at some of the particle size tests where you can see some of the color change, but we can think about how we can better represent that within the main text as well.
Yeah, and maybe just put a quote in there, a reference to other applications, because I don't want somebody to read this and say, oh, I mean, NROL, big groups around the world are working on finding ways to incorporate biochar in cement. And so I think that our findings are unique because it's only for this high quality cement needed for oil and gas, but it's not a general conclusion for all applications of cement. I think that would be fair.
Okay, see, Janice still has her hand up, and Stephen did, but he took it down. So, Stephen, if you still want to say something, let me know.
Okay, so thank you, Carrie. I was going to ask that question about, how much is 3% in terms of weight and all that, and you definitely helped with that. Back to the idea of gas and Thomas was asking why the people on the board might want to know more about that. Well, first of all, my understanding is that if some of these tests are expanded, like the hot water bath and the moving beyond 28 days, to get better results, to get more conclusive results. The reason I think that is good is that people looking at this from not inside of it, one of the things they really want to start getting at is how much gas, especially how much toxic gas, can biochar in this application be absorbing. It has everything to do with not just the environmentalists, but also like the governor's greenhouse gas program. They want to start seeing accurate data on how much emissions can be adsorbed, and so that's why more specific and as accurate as possible on gas, as far as I'm concerned.
Yeah, I mean, no, I understand that, but I think what Mike was alluding to before, some of the very recent studies out of Colorado State University on emissions from plugged wells, indicating that the gas emissions are very minimal. And so if you have a perfectly well plugged well, and all these numbers that we have seen from Dan Similey's group hold true, which I believe they do, published and peer reviewed, then the question is just, does it really matter, what is happening within the well if it doesn't get out in the very end? I would say in general, if you saturate your solvent with bentonite, which is a clay, and water, and all of the whole slew, the absorption of gas will probably be very minimal. That's my hypothesis. It would be very minimal. And I would definitely look for better solutions for mitigating any types of emissions beyond, using biochar as a fuel. I think biochar as a fuel is great from the perspective of reducing carbon footprint and so forth and so on. I think it's excellent. But for gas emissions, again, they're more or less able to totally prevent any types of emissions based on the recent studies that were conducted in Colorado. And if you had a failing well, you have much bigger problems, right? If you have a failing well, everything will blow out, and you need to repair it. I'm not an expert in this. I know Mike knows a lot more about this than I do, but I don't see the function of biochar from the perspective of reducing emissions if there are no emissions to begin with. If I was going to say, let's say in the future we see trace emissions, because there's always something, right? And one of the questions that I raised to the group, but we didn't really get to, is I've heard that emissions on the outside of the well is a thing. On the outside of the well, you basically have the well casing, you have the geological formation, and because there's a little lower back pressure on the outside of the well, you can have gas from a shale escaping up on the outside of the well, so not actually inside the well. I don't know the extent to which this is important anymore, but it used to be an issue. And so if you wanted to use biochar to reduce toxic gases, maybe especially beyond methane, so like VOCs and carcinogens, like cancer-producing emissions, and that was something actually Jeff Collette was studying in a recent publication he just put forward. You would probably rather consider a biochar filter on the outside, surrounding the whole well pad site. So you could have a nice, dry, high surface area solvent that could be replaced and put back and forth to capture toxic volatiles in the same way as you use activated carbon. That would make a lot more sense in my opinion. So you would force all the gases through that activated carbon or activated biochar filter on the outside. But inside, I don't expect it would do much because it would be so saturated with other stuff.
So
Thomas,
I'm going to try to focus the group a little bit, Janice, because now we're starting to get to things I think that were not a part of consideration in the bill or legislation. We're supposed to be
yes,
looking
they
at
are.
we're supposed to be looking at plugging and abandoning wells and how its use could be used in various forms. But I don't think we were told to look at as a carbon filter in soil or outside the well, if I'm
No.
if I'm understanding. So I want to be cognizant of your concern that we have an hour left and we want to make sure that we make it all the way through.
Okay. I need to reply to Thomas though, because in this report on page 50 and 51, which is coming right up, it talks about considering there are currently approximately 33,000 orphan wells in Colorado. If each well is plugged with 4.2 tons of biochar, average emissions would be reduced from 11.4 tons CO2e to 2.4 tons CO2e. By 2050, plugging all orphan wells with biochar would result in a greenhouse gas reduction of 296,810 tons CO2e. This reduction would account for approximately 1.5 of the 2005 emission levels associated with the oil and gas industry and is roughly equivalent to an annual removal of 65,000 cars from the road. So I think that the report needs to square this kind of a summary with what you're saying about it isn't so important to measure the gas, maybe. Like maybe can we get kind of some cohesion between those? Because I'm hearing, wow, this biochar thing really can make a huge difference in greenhouse gas, biochar in well plugging. But then as we're going through it, it sounds like, oh, absorption of gas isn't very important.
Okay. I get so there's a misconception. There's misunderstanding here. I'm
Okay.
glad you brought it up, Janice. So the amount of CO2 equivalents that can be captured by storing biochar in a well holds up all day long. What the group thought you were referring to was there's gases coming out from the shale, right? There's a lot of CO2 and especially methane coming out of the shale. We thought that you were referring to the extent to which the biochar could capture methane coming out from the shale. So that's two different things, okay? So what I'm saying is the biochar that's put in there will not be able to significantly capture methane escaping from the shale. However, everything you read holds up perfectly true. It's a beautiful way to sequester carbon and reduce carbon footprint and potentially result in carbon credits for the industry. So yeah, I think that clarified hopefully things.
Okay.
And I just wanted to point out, Karen mentioned it to us earlier, but our number of 33,000 orphan wells in Colorado is higher than what it actually is. So for the report that we're going to put out in July, it is going to be a bit lower than at 33,000. And
It's
it
going to
is
be
going to
more like
have
997. So like 1,000 wells. There's not 33,000 orphan wells in Colorado. Sorry, I just want to make sure, and Mike has his hands up, but for me, for am I understanding correctly? So the group is understanding correctly. From a previous study that we did with CSU, plugged wells in Colorado aren't leaking. And so, Janice, us determining whether or not putting biochar down the well in a process that we know has already been successful thus far for our studies would be difficult to determine because there is no leaking from appropriately plugged wells in Colorado. It's a different story if we look at recently abandoned wells, which do have emissions in many instances because some of the operators who have been unable to take care of their equipment appropriately. And so we do see some leaks. But if we use biochar to help plug that well, we're getting carbon equivalent sequestration, which overall then is a reduction in greenhouse gases. So I'm just making sure that I am understanding the conversation here and that we're all on the same page. And then Mike has a comment or question.
Okay, so that is where I would really like some help. Top of page 47, and I've read the reference to that equation. When does the potential of biochar's carbon sequestration abilities come to be? Does it absorb all that carbon once it comes out of the kiln before it is being transported to the well, before it is being put in cement? Because like you just talked about, once it's in the cement or when it's in the well, its absorption ability is very, very small. So when does it absorb all of the ability that you've calculated in that equation at the top of page 47 to say that, yes, you actually are realizing the carbon negative in the bar graph further down? I need to understand that. And that's where I would like a lot of help.
That's coming from us using the woody biomass. So it absorbs the carbon as the tree grows. And that's where those calculations are coming from. And then as it is converted, some of that carbon is stored as a stable form of carbon. And then when it gets put into the well, it becomes sequestered.
So
it's the carbonization process that is converting it from a short-term carbon that would normally decompose when the plant is, dead. And it's converting up to 50% of that carbon into a long-term carbon storage opportunity, which as long as you don't sell it for charcoal and you put it in oil wells, then you're sequestering it. But it's already happened before.
That I really appreciate that. And then skipping on down to the cost per well, a very modest number, that to get that, sort of carbon negative as a default, the tree grows. I get it, man. That's thank you for explaining that.
So it sounds to me, CSU folks, can we be a little more clear about how these numbers are derived and when the sequestration happens in the process and how we then came to the overall reduction numbers or the permanent sequestration?
Yes, and so I suggest to maybe develop a very tiny conceptual figure, because since this is a public document, to just understand what basically Kathleen helped us out explaining, conceptualize that in a little diagram, please, and then put the numbers on and explain your equation there. I think that would be super helpful.
Yeah, I'm hearing a little bit of confusion between sorption and sequestration, and so we can make sure both of those are defined very well.
Stephen. Oh,
yeah,
there you
sorry
go.
I really appreciate the conversation, particularly with Thomas. I think you clarified quite a few of my concerns. I think if we're discussing the benefits of kind of clarifying things throughout the report, it was a little unclear to me, I guess given my professional background, whether by referring to orphan wells, we were referring exclusively or necessarily to wells that have not yet been plugged, or if we include both unplugged and plugged wells, because it seems like that was the discussion in the early sections of the report. So I think we could benefit from just some language to clarify if we're referring exclusively to a well that has not yet been plugged but has been abandoned by the operator of record.
Thanks, Stephen. I see some head nodding, so.
Yes, we can do that. I was just typing what you were saying. Sorry about that.
Great. That was a great discussion. And I think we got a lot of things clarified. Any more conversation or clarification needed or comments for this section? Nice. Okay.
Okay, if we're ready to move on to the next task, I can do that. So the fifth task that we covered is on page 36. We were asked to look at whether or not there are any programs that exist to provide funding for the pilot program. It looks like there might be a couple of avenues for federal funding, which are written here. But we've had some internal discussions as well about potentially there are some private companies who would be interested in participating in a pilot program for this, but there aren't really any like grants or anything like programs that exist from the private entities to really discuss here. But I think it would be worth talking about potentially participating in these studies with some of the companies that we've been in contact with already. I don't know if Thomas has anything to add to that one.
Yeah, I mean, so the task was specifically whether or not there was any state and federal funds potentially available. So we were not asked to look into private. I can tell the group that after we started this project, there's a lot of interest, in becoming a part of this. A lot of companies, startup companies, are not only biochar manufacturers, but startup companies who are super interested in a potential opportunity to develop a company that can go in and plug these wells using new technologies and a approach including biochar. However, most startup companies, as you know, are often supported by venture, capitalist groups and investors and so forth. And the way they work is they go out to these venture, what is it called? Venture capitalist groups, and ask for funding. And they not normally need a pitch. And so I can tell you honestly that people are saying, hey, how do we become a part of the planning process so that you consider us when you start to do a pilot experiment? Because in that way they would get foot in the door, be a part of developing the solution that they then could financially benefit from in the future. Sorry about that horn. And I, of course, say, hey, I can't have that discussion at this point of time. I think in the next phase, we should look into all these different options, but we need advice from the state of Colorado, right? On make sure we do everything ethically and not introduce any types of bias and give people, benefits by being a part of this. However, we did talk about including potential companies and groups and institutes, and Kathleen represents some of them, right? And maybe she can help guide, as we move forward, because obviously you can imagine if the state of Colorado say, hey, you can be in but you cannot be in, that would be a big problem. So yes, I have said no to a lot of companies all the way out to the East Coast, New York and so forth, say, hey, I can't share anything with you at this point of time. Federal government has put money aside, about $500 million. I don't know how easy that is to get our hands on. Obviously, somebody would have to write the proposal. And so, how would such a proposal be put together? Would that be a CSU effort? Would that be all of us here as a group that put a proposal forward to the federal government and say, hey, a few universities in collaboration with the state of Colorado and all these other interest groups, are proposing to do a field study or something like that. So I think a lot of this discussion can wait till after July 1st, but we do need to all think about it, because Jason and I can certainly not necessarily just sit down and put a proposal together to develop a brand new program for how to plug orphan wells in the state of Colorado or beyond.
Great. Any other thoughts or comments about this section? And I would add, Thomas, I think it's okay if you wanted to put a line in there, like there might be potential for some private funding. You don't have to be specific about it, and just acknowledge that maybe the next step isn't going to be federal or state funding. Maybe maybe it's a public-private partnership.
Good idea.
Folks okay with this section? Can we move on to the next one? Okay, great.
Okay, the next section is task 6 on page 37, and it is assess the costs associated with using biochar in the plugging of an oil and gas well. An economic analysis was performed on plugging an oil and gas well without biochar and then with using biochar. And this is considering a biochar purchase price of $209 per ton. This does not include any carbon credits. And for the biochar in the well, it's 3% weight addition for the cement mixture, and then a 15% weight addition for the spacer mixture. And the results showed that with 4.2 tons, so just over 4 tons of biochar was used in a typical well with a measured depth of 6,800 feet. It's just around a 2% increase in costs. And this is mainly due to the purchase price of the biochar. There's some additional costs with transportation. There's also a small decrease in costs with the cement and water because you are adding that biochar into the well.
Kathleen, and then I have a question. Kathleen, you're on mute.
Somewhere in the report, you said you'd have to increase the amount of plasticizers. Did you factor that sort of thing in? And also, did you get those prices from the 3 people that you got biochar from?
I did not include the use of increasing plasticizers, so that's something I can talk with Holly about and see if we can incorporate that into the final report. And no, those I did not get the prices from where Holly got the biochar. It was within the websites of biochar producers, and then also on Puro Earth, there's a list of biochar prices. And I specifically only included prices for North America.
Even though she didn't use the specific companies that we looked at, the prices of the biochar, if we would have purchased it ourselves, fell within the range of what Brooke calculated.
And I do want to add, in the results section, I mentioned that adding 15% weight of the biochar to the spacer, it is quite a bit of volume, and it does decrease the density of the spacer mixture. And that I mentioned it is an area of concern, and we've talked about it earlier, that more testing needs to be done to ensure that the spacer is the proper parameters to include in the well properly. And yeah, it's really important for the go, no go to make sure we have proper mixture of the biochar, the bentonite, and the water in there. As 92% of the biochar is in that spacer mixture, and only 8% is in that cement mixture.
Yeah, and then just I want to say one thing, and that is there is a new type of biochar out in the market from a company out in the East Coast. I don't want to get into who and where, but it's a very different form of biochar that is nearly hard as a diamond. And so that there is the potential as we move forward, and we have some of it in our lab right now. It's basically pelletized. Kathleen knows what I'm talking about, I think. Pelletized biochar. And so suddenly it's a totally different biochar, but it potentially would be perfect for this type of application because it would ease mixture, and the compression issue would be looking very differently as compared to if you're using powder or ground biochar. So there's some new physical forms that are made a little bit differently, still biochar, that potentially could be tested. And so anyways, I just wanted to put it out there, especially if Kathleen has some feedback with respect to that company that we have started to talk to a little bit for some other projects. But it's pelletized biochar.
Yeah, I've heard there's only a few doing that. So I'm wondering, what the price point will be for that. But if you're ordering 4 tons at a time, I think you're going to get a decent price because that's not the average order these days.
We could potentially get it for free, but that's a different discussion.
That was what I was going to say earlier, but I've had that discussion already with Brooke and Holly, that if they're selling the carbon credits and you don't need them, and honestly, 4 tons of biochar is only going to get you $1,000, then you can get it for free. It's then just a question of the transportation.
That's right. Correct.
So Mike has his hand up. Mike, can I ask a question first? The assumption, I just want to make sure I'm actually comfortable with this, but I want to make sure everybody else in the group is, that this kind of sample of a well that we're using is a vertical well and 6,800 feet. And I think that's appropriate because we aren't plugging horizontal wells yet because those are newer. So that did seem appropriate to me. I'm 6,800 feet. I'm wondering where you all came up with 6,800 feet. I think I'm supportive, but I was just curious.
Yeah, Carmia connected me with a petroleum engineer at BLM, and he had actually done his PhD on some of he used the measured depths in his PhD. So he was able to share some information with me on average measured depths for each county across Colorado. And the 6,800 is for all counties, the average depth, not of the orphan wells, but of all wells within the state of Colorado.
Awesome. Thanks, Brooke. Mike.
Commissioner McGowan, I'll start there. 6,800 foot is perfect. And as you guys know, when you're plugging a horizontal well, you don't do anything to plug the part that's horizontal. You just plug the vertical part, which is 6,800 foot here or there or anywhere. So I like that. A quick thing to add there, Brooke, in Appendix C, maybe you could add, in addition to what you have on this standard well, some other oil field nomenclature to say, instead of tons, sacks of cement. I think that would be really easy to come by, or just other ways to break up your columns between like English and SI units or something like that. I think folks in industry are used to looking at it in terms of sacks. The one other thing I wanted to bring up in terms of the polycarboxylate plasticizer, that is a construction industry thing. We do not use that in oil field additives. There's certainly many other oil field cement additives that we use to make sure the water loss is accurate, the viscosity is accurate. So I think that would be a big change from any of the testing you've done to go forward and say the plasticizers are not in oil field use. We're going to have to come up with something else completely different to make sure that the water, the biochar, steals from the rest of the cement chemistry is made up in a different way. So that's another huge thing you guys are going to have to do in the lab. I think those were the three things I was going to say.
Yeah, and that's a good point, Mike, and Carrie's work. Look, one of the important things we didn't summarize is that when you add biochar in as an additive to this cement, it impacts the fluidity of the cement. So basically how easily you can pour that cement out. And as you increase the amount of biochar, that number just increases dramatically. And in a way, if I understood it correctly, Carrie can correct me if I'm wrong here, a way to get around some of that is by adding in some plasticizer, right? Carrie, did I get that right?
Yeah, so the reason, I mean, I'm definitely not like an expert in this field either. So it's like if I use the wrong plasticizer, that's completely my mistake. But the way I decided to use the PCE plasticizer is because I did, like Thomas said, the viscosity studies, and I was advised by the company supplying me with cement that like adding something that uses up a lot of water like biochar, like one of the biggest things that I should consider is that viscosity. And so in my reading, I found that the PCE plasticizer was like one of the best plasticizers at reducing water usage. So that was a green flag to me. And then I also asked my supplier if there's a specific type of plasticizer that they use, and he just said no, it's whatever makes the viscosity better. So um that's kind of how I decided to use the PCE. It's really good information that that's not currently used. That's something that I didn't know. um and if I need to retest some stuff using a different plasticizer, I can definitely do that.
Yeah, and I just think that's a very important point, right? Because it's not only about the fact that when we increase the amount of biochar, that it might impact the strengths or chemical properties, but it also impacts, the viscosity. And viscosity is a big deal for these guys who go out and plug our wells. Just talk to your state engineer. I think he'd be very worried if the viscosity, even though it's Carrie in her report, in her piece in the report, is comparing these viscosities to motor oil. And so in a race car, that would be the upper range of viscosity we're seeing. And in your general, Ford Focus or whatever, you would be at the lower range. So it's actually viscosities that you can observe within the range of motor oils that are available on the market. But that actually is a dramatic increase in viscosity for the industry who do this well plugging. So anyways.
I actually have a clarifying question. Are we talking about not using any plasticizers at all, or just not using the PCE?
When I talk with folks, we don't use polycarboxylate at all in oil well cements. You would use something else. And
Okay.
yes, A plus provided your cement. They are a oil well plugger. They would have good knowledge, but there's just a enormous breadth of folks out there that do oil field cement chemistry that you would use a different. Again, before you go to commission to ask for a variance, you're going to want to test this very thoroughly. And then you're not going to want to depart and go and bring something in from the construction industry. You're going to say, this is tried and true. This has been used in oil and gas chemistry, oil well cementing. This is what's going to get you that result. Commissioners now may have a variance. And then the other thing, Brooke, the only thing I didn't understand, or not didn't understand but what may be helpful to convert from the centistokes of kinematic viscosity to centipoise of dynamic viscosity. I don't have a background in that, but that would be another thing to say. In the oil and gas industry, we're using centipoise. If I could see the numbers in dynamic viscosity, that might be easier for me to appreciate. So just something else, if it's easy to convert or have those two side by side, would be helpful.
Okay.
Can I just ask, is there a reason you don't use polycarboxylate plasticizer? Oh, wait, where did it go?
I
Oh,
don't
there it
have
is.
an answer.
There it is.
Again, it would be like a major oil field service company that would be able to better answer that. I don't have the answer.
Okay, I was just curious.
I think lastly, we weren't really able to get a good feel for like what the target viscosity range actually is for these cement pouring processes. So we really were just trying to not change the viscosity as much as possible. So if anyone has any guidance for us to find like an actual acceptable viscosity range, that would be really helpful for us.
I'll just throw out in dynamic viscosity and centipoise, some of the stuff I was looking at, you're say 90 to 130 centipoise. I don't know what that is in centistokes in kinematic viscosity. So again, it's something else you guys are gonna have to research, but certainly work with oil field, cement folks that have that number on their side and compare with that.
Thanks.
Mike, what do you then you're a national organization that comes up with standards that a lot of folks follow. Can you remind me what that's called, please?
API, American Petroleum Institute.
API. Okay. I was thinking it's not API, but it is API. Are they going to have some recommendations about viscosity and why they're looking for a certain amount in the liquids that is in between the spacer, or do you think they won't have that?
Let's just focus on the cement itself. You would want a viscosity to be able to mix it on surface, pump
Oh,
it
right.
down hole, and have it end up where it needs to be. So obviously something too thick, as you guys are already aware, is not going to make it down there. But it really doesn't matter. You still need to satisfy 408, which says in 24 hours, I need this much compressive strength. 48, 72 hours, I need this much compressive strength. And then the other part is the 3 milliliters of free water per 250 milliliters of cement. So if you can satisfy those things, hey, we're within the realm of the ECMC's regs, and I would say the onshore order for BLM is probably very similar. We all borrow from each other. So viscosity, you need to get it down whole, but you ultimately have to say, I need these free water and compressive strength to meet the regulations.
Did I hear correctly that a good viscosity would be 90 to 130 centipoise?
I looked at some, I emailed the drilling engineer and I said, hey, remind me in the last job we pumped, what was the centipoise? And that's what I saw as a range on some of those reports.
So I know I can say, right. So I tried, we didn't put this in the report because it wasn't a good mixture, but I did try a 3% mix that had like excess plasticizer. So it was at least with the plasticizer I was using, the lowest viscosity that was like possibly achieved, and it was still nowhere close to that. So like, and it was a really poorly performing cement as well. it kind of just fell apart. So like if the viscosity that I have here for the 3%, which is 280, is too viscous to use, then like I don't think we should use the 3% because the 3% that was more viscous was like unusable once it was cured. So in that case, we'd have to go down to 1% to have it be workable.
Yeah, so to make a long story short, honestly, I mean, to go to the conclusion with respect to cement and using biochar as an additive, I think in the short term, our recommendation is not to mess with it. I mean, since the carbon sequestration potential of adding biochar to cement is so little compared to using biochar as a filler in between the plug, I just I don't think it's something we need to consider in the short term, except from if somebody can make a good case for 1% biochar as being beneficial. But to go through all the regulatory hassle and so forth to allow for 1%, I think it's certainly something one can look into long term, but short term, the big potential here is to use biochar as a filler. And in that way, we would not jeopardize the integrity of these cement plugs because they are really the most important thing for successful well plugging. Except from if we can prove that 1% biochar, since by volume is quite a bit, would improve the sulfate and especially the chloride attack. Hey, now we're talking. So we're not doing it necessarily from the perspective of sequestering carbon, but we are doing it from the perspective of providing a better cement with better physical chemical properties that will last longer, down the road. And so from that perspective, I think it's very, very interesting because 1% might be just sufficient.
So the figure 12 on page 49, could you break that out to say how much of that benefit is from 3% in the cement and how much of that benefit is from the 15% in the spacer? That would be good. So then you could say, hey, following up on Thomas's comments.
Yeah, and as
Absolutely.
mentioned earlier, 92% of the biochar is in the spacer. So I can break it up further into that table to make it more visual for everyone, certainly.
Yeah, and just to clarify, because Janice had a little comment about it too. Basically, our kind of question for you is whether that extra 6 or 8%, whatever, if 90, what was it, 92% is in the filler or 94, Brooke?
It's 8%.
8, yeah. So if that additional 8% is worth it to you, 3% does seem to be very promising. So it's really up to you all to decide whether or not the additional testing we would need to do and the additional regulatory components of adding something to the cement, if that is worth it to you, or whether or not it's sufficient to do just the 92% in the filler or in the spacer.
Just as a caveat, 3% is promising if it's not too viscous. If it is too viscous, then it's not promising because we can't use it.
Exactly. And so if we go down to 1% and we improve the chemical properties of the cement, which, hey, I'm all about engineering better cement. We all are. If it just adds, I mean, if you can more or less do it for free and it improves the chemical resistance towards chloride, that's I would be interested in looking into that.
So sorry, I want to clarify also, as we contemplate what a pilot might look like, is one of the questions this group should or might want to answer is, for a pilot, is it worth the time, the effort, the energy to consider it as an additive to cement and or just looking at it as a material for spacer? So something for
Yes.
this group okay, great. Something for this group to think about as they're thinking about recommendations. Okay, great. I'm cognizant that we're at 11:41. So are folks okay with this section now and moving on to the next? Great.
So the seventh task was to determine how much biochar is available in the state. And that's something the Forest Service was already tangentially working on, and we just kind of capitalized on some work they were already doing. So maybe Ashley can talk through what she did, and then I'll walk through the calculations that converted it to biochar for us.
Yeah, hey everybody. I'm pulling it up right now. We were already using forest inventory and analysis FIA data to complete our statewide biomass assessment that looks at live material in Colorado's forests to help pull existing biomass out of the forest for different wildfire efforts and to increase our wood utilization markets across the state. And so we just changed a couple different things to look at standing dead wood and get these estimates. So everything was done in a program called R, and the U.S. Forest Service Rocky Mountain Research Station, this is page 41, developed a package to run estimates similar to this. So we that's kind of how we arrived at these estimates, and I can go into more detail if people are curious. But we were able to filter for only counties in Colorado that have enough forested land and lands that are not considered reserved. So it doesn't include wilderness areas or national park land. And it estimates the material that would be able to theoretically remove from the forest. So there's not a significant amount of rotten material. There might be some, but as from a safety viewpoint, you could remove the material. It does not assess like roads, like how far away a road is to the material. It just can't get at that level of detail, but we were able to break it out by different forest types, ownership groups, and then looking at it, I did not include to Holly the figures for counties, which could be pretty helpful with kind of determining spatially where there's a lot of material and where that lines up with oil and gas wells. So that's something I can include if there's interest, but we kind of found what we would expect to see with a lot of the recent insect and disease outbreaks with spruce and pine beetles, that Engelmann and lodgepole pine forest types had the most standing dead material. And then, of course, Forest Service dominates in terms of how much land is owned by different ownership groups. Forest Service owns the most. So that came out in the results, and we were able to break it out provide these estimates in cubic feet, which is pretty standard, a standard Forest Service or forestry unit. So there might be more detail than needed in what I gave to Holly, but we can further refine some of this stuff too.
But Ashley, overall, I think the end of the discussion is there might be a billion to almost 2 billion CCF of biochar, in my understanding. So there's plenty of biochar. Okay.
Yes, there's a lot. There's more
Yes.
than enough.
We put that number in context, I think, later on in the report. I don't remember off the top of my head exactly where we converted those numbers.
I'll be playing industry and a state. One just for clarification, when you do the carbon emission reduction calculation, Brute, you took the transport of biochar from the forest to the biochar manufacturing facility into account, right? And accounted for about 100 miles. Is that correct, if I remember correctly?
Yeah, so I accounted for the biomass transport to the biochar production facility with an assumption of a 100-mile round trip distance.
And then also from after manufacturing, another 100 miles to the oil and gas wells.
115 miles from the biochar production facility to the oil and gas wells.
Okay, okay.
So again, we're going to run out of time here. Janice, I'm sorry. Um, Upshot is there's lots of woody biomass and lots of availability of biochar. Kathleen, you want to ask a question real quick, and then I'm going to move the group on to the next section.
Page 40 says you have 42 billion tons of biochar in Colorado. Is that right? Or am I misunderstanding it?
But I think per this conversation, not all of it is accessible and not all of it is usable. And so if you go down to this summary, right, it's the 2 billion tons or CCF, which is still a lot.
It's the conversion of CCF to tons. That's what Kathleen is looking at.
Got it. All right.
And that was based on density.
Incredible. Yeah, I'd love to see what that is for all the states if that's something that's available.
Okay, next section.
Okay, so next section is task 8, which is on page 46. And this is examine whether the use of biochar in the plugging of oil and gas wells is consistent with the state's short-term and long-term greenhouse gas and pollution reduction goals, taking into consideration the emission of greenhouse gases and other pollutants caused by the production of biochar and the use of biochar in the plugging of oil and gas wells. A life cycle assessment was performed to assess the use of woody biochar on greenhouse gas emissions associated with the typical well plugging process. This is based on a vertical well with a measured depth of 6,800 feet, and the inputs and outputs from the economic analysis form the basis for the life cycle assessment in terms of the well plugging process. The functional unit was the plugging of one well, and the LCA system boundary for the biochar production included activities such as the biomass transport from the forest to the biochar production facility, any pretreatment required on the biomass, the thermochemical conversion of the biomass to biochar, the biochar transport to the well, and then the application into that well. For the well plugging system boundary, it included the equipment and materials transport to that well, any fuel required for that equipment at the well to be used, and then the material inputs such as cement, bentonite, and water into that well. The carbon sequestration was based on a EBC calculation, and it's based on the biochar carbon content and its stability with 100% permanence factor assumed because it is being permanently sealed in the well. 5 different biochar production methods were analyzed, and this is coming from a recent USBI 2023 market report. 82% of respondents said that the biochar production methods used were either stationary systems with a rotary kiln reactor, an auger reactor, and a batch reactor, or portable mobile systems such as a retort and carbonizer. And each of those, a life cycle assessment was performed with distinct features and general assumptions based on their conversion method. And then results showed that without biochar in the well, just the standard conventional well plugging process emits 11.4 tons of CO2 equivalents. And this reduces anywhere from 0.64 to 6.11 tons of CO2 equivalents per well plugged, depending on that biochar thermochemical conversion method. The mobile carbonizer and stationary systems showed comparable emissions, and they all were the lowest emissions. That mobile carbonizer achieved the highest net negative emissions, and then the portable retort had the highest emissions despite having a higher carbon sequestration value because it does use quite a bit of diesel and propane used for the startup compared to the other methods.
I know I'm not supposed to ask questions, but I will. For clarifications, you can produce syngas when you do pyrolysis that can be used for energy production. that could actually, I think, count towards carbon reduction. Was that included? So for example, you produce methane and you can produce hydrogen, right? That can be used to produce electricity.
Yeah, that's correct. It was included. Any syngas produced was recycled at 75% efficiency and used to replace any natural gas needed in the drying process for pre-processing and in the pyrolysis process where natural gas was used.
Okay, thanks.
And then, as mentioned earlier, I did have in that report that with those an average emissions between the five methods of 2.4 tons of CO2 equivalents per well, this would reduce the 2005 emission levels of the oil and gas industry by 1.5%. This is on the assumption of 33,000 orphan wells. This is going to decrease to around 900. So it's going to be a much smaller impact on those 2005 base level emissions.
Any questions or comments about this section? And then if not, I'd like to talk to the group about whether or not you want to go through the next. What do we have? One more section left and then the conclusion. And then, because I think we're going to run out of time and Janice is still here. I guess the question is whether or not you all want me to set up a meeting at the end of June to see an updated version of this and make your recommendation, or if you want to talk about a recommendation today. I do have to leave at noon, and this is going to be a handoff to Commissioner Mesner, so I want to make sure that whatever we decide to do works in his schedule as well.
Commissioner, I would like to talk about a recommendation today, even if it's just a straw poll on what folks think.
Okay, recognizing that we really don't have all of our group here.
Correct.
Hopefully we all kind of have a general idea based on the information from this draft report about what we think would be the next step in the recommendation. Do folks want to throw some ideas out there? Mike, do you want to start?
I would. Again, I am so inspired by the work everyone has done. Please pat yourselves on the back. I have learned so much from this. Thank you for enriching me in that. I'm going to, preface my comments with that because I want to say this is not ready for a downhole pilot. I'm excited for what this brings next. Probably a lot more lab work to say, how could you get cement with biochar in it ready for a downhole pilot? But I would say this is not ready for a downhole pilot.
But it's a question whether it's ready for developing pilot scale experiments. The next 6 months would basically be focused on designing mesoscale experiments that then eventually, I guess, if they're successful, could result in field experiments. So we're not at this point of time, I think, voting about whether or not this should ever be a field experiment, but more whether or not we, over the next 6 months, should try to design with the industry. And it'll be a very different team, obviously, very different team over the next 6 months, whether we should design experiments that can verify whether or not to move on to a field experiment.
That makes sense.
Janice.
Aaron. Page 9 of the bill says that the recommendations pursuant to this subsection must include at a minimum recommendations regarding the estimated costs to implement a pilot program, the duration of the pilot program, a detailed plan for the implementation of the pilot program by the commission, and a description of any opportunities to work with or receive funding from federal agencies, et cetera, et cetera. So I think that if we that we don't have that information yet, it's a little premature to say that we shouldn't do a pilot.
But wouldn't that be in the recommendation for, that would be, Janice, if I'm understanding, this first part is we come up with a draft report about in general the efficacy of biochar for plugging and abandoning a well. And the focus here has been on additive for cement and spacer. And then the next step for this group would be, should there be a pilot that follows this? And your concern was, well, the intent was for it to be done on an actual well.
Yes.
So far, I'm hearing some mixed conversation about, are we actually ready to do something downhole in an actual well versus more in depth. I think it was called mesoscale experimentation to show in downhole types of situations and different kinds of amounts of biochar, what viscosity, whatever, that might be am I hearing you right, Thomas, that might be the recommendation for what the pilot is, not an actual downhole, let's put it in a well.
Yeah.
I might
Yeah.
be misunderstanding, but then
No.
if that
You
Okay, so if that is the recommendation, what CSU would put together then is what everything you laid out in section 9. How much would it cost to do this? What would the experimentation be? What materials where might we get funding? That would be that part 2. That's in part 2.
That's correct. And we would be actually also as a part 2, we would be reaching out to industry partners. That's a part of it. We need to have industry regulators, all people on board to develop such a plan. And then the execution of experiment part, CSU part, some other universities part at the national labs. Just like the first time somebody developed a well plugging strategy for the ongoing wells. They were trying to figure out how much bentonite should we put in these wells, or can we put in the wells, how much produced water, how do we do the cement, and so forth and so on. Now we would have to reconsider all of that with a concept of implementing biochar as a filler, biochar potentially, if the group wants us to move forward with that, as an additive for cement, and do exactly the same test as was done decades ago for the ongoing processes. And then we lay out a plan for that. We execute the mesoscale experiments. And if they all turn out great and people are excited about actually trying this out in the field, that would be phase 3. It's a little, yeah, the what is it called? Technology readiness level, TDL level, right? We start out and this is more or less an assessment. Is this a bad idea or is it a good idea? You got some numbers you can consider with respect to if the goal is to reduce greenhouse gases. Well, I'd be happy with 3% reduction or 8% reduction, in greenhouse gases by doing this. Yes, we are. Okay, let's move on to the next. And I think there's a lot of other potential things that we should consider as we plan pilots or mesoscale experiments, because there's so many other potential benefits of using biochar at or around these wells. But that's something I think the state of Colorado needs to decide. When you haul all that biochar to these well pad sites, there's a potential for using these biochars also for restoration, right? Well pad site restoration is a big challenge for the industry because of compaction, because of residual pesticides, and biochar can potentially help tremendously on getting 2 good growing seasons of grass going, so we can, people can get signed off. That's a little bit different. But anyways, the next would be a planning of whatever it would take to do these mesoscale experiments to either say, yes, let's move on to field, or no, it's a really bad idea, it's not worth it.
Okay, so I see that Jana has her hand up. It is noon. I unfortunately have another meeting. Do you all want to so I'm here till Friday. I can try to schedule something with us before I go and take another, an hour for us to kind of go through some further recommendations. Or I can give you all more time and let Commissioner Mesner try to tackle this. Jenna, go ahead and comment, and then let's try to wrap this up and figure out what our next steps are and when you all would like to meet again next. And I think it has to be before the end of June. Jenna.
Thanks, Karen. Yeah, I was just wondering about that too, if maybe we can, do our straw poll through email, or if we actually need to have another meeting. I'll leave that up to the group. For me, I think for CDPHE at this phase, I think this phase is just trying to decide whether we want to give them the green light to design what a pilot program would look like. The next phase is where, we're talking about doing actual work in the field. So, I mean, I think CDPHE would be comfortable with at least going forward with seeing what the design of a pilot program would be.
And what I think I hear some of the group also saying is that design would be meso experimentation, not quite ready yet for prime time, using an actual of orphaned well. That's what I'm hearing.
I mean, that's correct. I mean, but if you say, hey, we want if we want you to design a phase 2 and a phase 3 to this, phase 1 being the assessment, phase 2 being a mesoscale experimentation that is required in order to even move on to a phase 3, which would be a much higher TDL level, which would be experimentation in the field in close collaboration with the industry or private well owners. You have to decide whether we just need to develop phase 2 or phase 3 or both.
So what do folks think about as part of a recommendation? It would be a multi-phase pilot with further experimentation first and then real world testing on a well. Are folks open to that?
Karen?
Okay. Yes.
I know you don't want me to talk, but I need to say something here. The bill was written with this, already taken care of. And I think diverting from the bill at this point is not a good thing to do. It's already part of the law, Karen.
I think if you're going to stick with this, I think the recommendation from the group is going to be no recommendation for a downhole study. That's what I'm hearing from CDPHE. I think that's what you're going to hear from our ECMC folks. I think you're hearing it from an industry person who actually operates the wells, and I think you're hearing it from CSU themselves. And so,
well, no, they're saying the bill actually says that this needs to be planned for a pilot. Now we're talking about putting another step in for meso experiments. I understand that, but I still think a downhole plan needs to be put into action to accommodate the law as it was written. People need to look at the act.
Janice, there's a bifurcation. We can stop here, and this group says we don't think we should move forward. We're not ready to do downhole, and we're going to submit this report, and it will get posted. Or the group can say, we do recommend that we draft what a pilot would look like. And what I'm hearing from the group is that draft would have 2 phases. One, which is more experimentation, moving and leading to a actual downhole pilot. And that what you're going to see in that draft pilot study is both of those phases with cost estimates, what would have to get done, who could potentially do it, what the partners would be, that whole kind of section 9 that you mentioned.
Page 9.
Yeah.
That's correct. That's correct. We're not eliminating field. We're just doing in order that would allow us to do field. I think I
you
agree
have
with
until December 1 to make those recommendations. It's in there that no later than December 1 will the university submit a draft report describing its recommendations for the development of a pilot program. So you can put those things in there, but it does want to see what a pilot program would look like.
Yes, if this group says yes, go ahead, put something together for a pilot. And I think what this group is saying, we would be interested in that, but we want to see several phases.
Okay, that's fine. I'm just saying, let's not take out all talk of downhole work. It needs to be addressed in the descriptions and in the planning, even if we don't do it right away, it still needs to be part of the planning. That's all I'm saying.
I think that's what the group is saying. I think we're saying the same thing, but in a different way.
Okay.
all we're saying is that in between an assessment based on a literature study and a few lab-based studies, the next step is, well, we need to scale up. Scaling in engineering science is always the biggest challenge. In order to scale up, make sure that everything will work out in the field, we need to do mesoscale experiments. That will cost money and time. And if all of that works out and the industry says, yeah, this looks really promising, and regulator says, yeah, green light, we are happy, let's move forward. Then we can go in and do field experiments with selected wells. And if that all turn out right, we can implement it as law.
Okay. So my apologies. I'm 6 months. I'm 6 months. I'm 6 minutes late for my next meeting. Do you all want a couple weeks to meet again, and I will work with Commissioner Mesner and CSU on a date and a time? Is that okay? And
Yeah.
I will work to put together the next Zoom invite. It will be before the end of June. CSU, can you integrate some of these recommendations? I will ping the group again to say, if you missed this meeting or if you had more comments, you need to send them ASAP so that you can send the draft up before the group meets again. We can sign off on this final recommendation, and then the group can talk about what they want. They can recommend whether or not they want to move on to draft stage and what they want to see in the draft. That your next step, what a pilot would look like. I
Perfect.
appreciate everyone's time. Janice, I appreciate you working through with me. I know sometimes we feel like we're button heads, but we're not really. Okay, everyone's good?
Yeah.
All
Thank you
right.
so much.
Thanks, everybody.
Thanks all.